Table 312.6 is located in the 2020 National Electrical Code, and it provides the minimum sizes of conduit bodies for various combinations of conductor sizes and quantities. For 3 number 2/0 American wire gauge conductors, the minimum conduit body size required is 6 inches. To determine the correct conduit body size using Table 312.6, firstly, locate the column corresponding to the number of conductors in your raceway, in this case, 3. Secondly, find the row corresponding to the largest conductor size in your raceway, in this case, number 2/0 American wire gauge. Thirdly, the intersection of the column and row will provide the minimum required conduit body size. In this case, the intersection of the column for 3 conductors and the row for number 2/0 American wire gauge conductors is 6 inches. Therefore, the correct size of the conduit body for 3 number 2/0 American wire gauge conductors is 6 inches. Let's delve deeper into understanding conduit bodies and the NEC requirements for their sizing. Conduit bodies, often referred to as conduits, are essential components in electrical conduit systems. They provide access to conductors for pulling, splicing, and maintenance, while also allowing for changes in direction and serving as mounting points for fixtures and devices. The neck, specifically Article 314, covers the requirements for outlet device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. Section 314.28 addresses the sizing of pull and junction boxes and conduit bodies, which is crucial for ensuring adequate space for conductors and preventing damage during installation and operation. Table 312.6 is the go-to resource for determining the minimum size of conduit bodies based on the number and size of conductors. This table is specifically designed for conduit bodies containing conductors of size 6 American wire gauge and larger. The table ensures that there is sufficient space within the conduit body to accommodate the conductors without overcrowding, which could lead to insulation damage, overheating, or difficulty in pulling conductors. When selecting a conduit body, it's important to consider the following factors: firstly, the number of conductors; secondly, the size of the conductors; and thirdly, the type of conduit body. The number of conductors directly impacts the required volume of the conduit body. More conductors necessitate a larger conduit body to provide adequate space. The size of the conductors also plays a significant role. Larger conductors, such as number 2/0 American wire gauge, require more space due to their increased diameter and insulation thickness. Different types of conduit bodies are available, including LB fittings, LL fittings, LR fittings, and T fittings. Each type serves a specific purpose and has its own set of dimensions. It's essential to choose the appropriate type of conduit body for the application and ensure that it meets the NEC requirements for sizing. To illustrate the application of Table 312.6, let's consider a few more examples. Firstly, if you have 4 number 4 American wire gauge conductors, you would locate the column corresponding to 4 conductors and the row corresponding to number 4 American wire gauge conductors. The intersection of these two would dictate the minimum conduit body size. Secondly, if you have 2 number 3/0 American wire gauge conductors, you would locate the column for 2 conductors and the row for number 3/0 American wire gauge conductors. The intersection would then specify the minimum required conduit body size. It's crucial to note that Table 312.6 provides the minimum required size. In some cases, it may be necessary to use a larger conduit body to facilitate easier wire pulling or to accommodate future expansion. Additionally, if the conduit body contains splices or taps, the volume requirements may be different, as outlined in other sections of Article 314. Always refer to the latest edition of the NEC and consult with a qualified electrical inspector to ensure compliance with all applicable codes and regulations. Improperly sized conduit bodies can lead to code violations, safety hazards, and potential equipment failure. Remember that the NEC is updated regularly to reflect changes in technology and best practices. Staying current with the latest edition is essential for all electrical professionals. In addition to Table 312.6, other sections of the NEC may also influence the selection and installation of conduit bodies. For example, Section 314.16 covers the volume allowance per conductor in outlet and junction boxes, which can be relevant when the conduit body is used as a junction point. Section 314.27 addresses the mounting and support of conduit bodies, ensuring that they are securely fastened and protected from physical damage. Furthermore, the NEC provides guidelines on the proper use of fittings and connectors to ensure a watertight and secure connection between the conduit body and the conduit. These fittings must be listed for the intended use and installed according to the manufacturer's instructions. In summary, selecting the correct size of conduit body is a critical aspect of electrical installations. Table 312.60 of the NEC provides a straightforward method for determining the minimum size based on the number and size of conductors. However, it's essential to consider other factors such as the type of conduit body, the presence of splices or taps, and the overall installation environment. By following the NEC guidelines and consulting with qualified professionals, you can ensure a safe and compliant electrical system. Let's further explore the practical implications of using appropriately sized conduit bodies versus using undersized ones. When a conduit body is correctly sized, it allows for easy pulling of conductors, reducing the risk of insulation damage. Damaged insulation can lead to short circuits, ground faults, and even electrical fires. A correctly sized conduit body also provides ample space for heat dissipation. Electrical conductors generate heat when carrying current, and if the heat cannot dissipate effectively, it can lead to overheating and premature failure of the conductors. Overheating can also degrade the insulation, further increasing the risk of electrical hazards. Furthermore, a correctly sized conduit body facilitates future modifications or expansions to the electrical system. If additional conductors need to be added, there will be sufficient space within the conduit body to accommodate them without having to replace the entire fitting. On the other hand, using an undersized conduit body can have several negative consequences. Firstly, it can make it extremely difficult to pull conductors, potentially damaging the insulation. Secondly, it can restrict heat dissipation, leading to overheating and premature failure of the conductors. Thirdly, it can make it impossible to add additional conductors in the future, limiting the flexibility of the electrical system. In addition to the technical aspects of conduit body sizing, it's also important to consider the economic implications. Using the correct size of conduit body may initially cost slightly more than using an undersized one. However, the long-term benefits of improved reliability, reduced maintenance costs, and increased safety far outweigh the initial cost difference. Furthermore, using undersized conduit bodies can lead to code violations, which can result in fines, project delays, and even legal liabilities. Therefore, it's always best to err on the side of caution and use a conduit body that is slightly larger than the minimum required size. This provides a margin of safety and ensures that the electrical system will operate reliably for years to come. Let's consider some additional scenarios to further illustrate the importance of proper conduit body sizing. Scenario 1. A commercial building is being wired with numerous branch circuits. The electricians are using undersized conduit bodies in an attempt to save money on materials. As a result, the conductors are difficult to pull, and the insulation is damaged in several locations. Over time, the damaged insulation leads to short circuits and ground faults, causing frequent power outages and disrupting business operations. The building owner is forced to spend a significant amount of money on repairs and upgrades to the electrical system. Scenario 2. An industrial facility is expanding its production capacity. The electrical system needs to be upgraded to accommodate the increased load. However, the existing conduit bodies are undersized and cannot accommodate the additional conductors. The facility owner is forced to replace all of the conduit bodies, resulting in a significant expense and a lengthy shutdown of production. Scenario 3. A residential homeowner is installing a new electrical circuit for a hot tub. The homeowner attempts to save money by using an undersized conduit body. As a result, the conductors overheat and cause a fire. The fire damages the house and endangers the lives of the occupants. These scenarios highlight the potential consequences of using undersized conduit bodies. It's essential to prioritize safety and compliance with the NEC when selecting and installing electrical components. In addition to the size of the conduit body, it's also important to consider the material. Conduit bodies are typically made of metal or non-metallic materials. Metal conduit bodies are typically made of aluminum or steel and are suitable for use in a wide range of applications. They provide excellent protection against physical damage and are often required in hazardous locations. Non-metallic conduit bodies are typically made of PVC or fiberglass and are lightweight, corrosion-resistant, and easy to install. They are commonly used in residential and commercial applications where physical protection is not a primary concern. When selecting a conduit body material, it's important to consider the environmental conditions, the potential for physical damage, and the applicable codes and regulations. In some cases, the NEC may require the use of specific types of conduit bodies in certain locations. For example, in wet locations, the NEC requires the use of watertight conduit bodies and fittings. In hazardous locations, the NEC requires the use of explosion-proof conduit bodies and fittings. Always consult with a qualified electrical inspector to ensure that the selected conduit body material is appropriate for the application. Finally, it's important to emphasize the importance of proper installation techniques. Even if the correct size and material of conduit body are selected, improper installation can still lead to problems. Conduit bodies should be securely mounted and supported to prevent them from being damaged or dislodged. Fittings and connectors should be properly tightened to ensure a watertight and secure connection. Conductors should be carefully pulled to avoid damaging the insulation. All work should be performed by qualified electricians who are familiar with the NEC and local codes. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all applicable regulations. Remember that electrical work can be dangerous, and it's always best to leave it to the professionals. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. In conclusion, understanding conduit body sizing is crucial for safe and compliant electrical installations. Table 312.6 in the National Electrical Code NEC provides the necessary guidelines for determining the minimum size of conduit bodies based on the number and size of conductors. Always consider factors like conductor size, the number of conductors, the type of conduit body, and the material it's made from. It's not just about meeting the minimum requirements, but also about ensuring ease of installation, heat dissipation, and future flexibility. Using appropriately sized conduit bodies prevents insulation damage, overheating, and potential safety hazards. Scenarios in commercial, industrial, and residential settings show the consequences of undersized conduit bodies ranging from frequent power outages to fire hazards. Proper installation techniques, including secure mounting and correct fitting connections, are equally important. And always consult with qualified electrical professionals to ensure code compliance and safety. Remember, electrical work should be performed by those with the proper training and qualifications.